Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the IB Chemistry HL May 2023 examinations. This is a paper 2 question. Let's get started. The initial rate of reaction was determined for the reaction between bromide ions Br minus aqueous and bromate ions BrO3 minus aqueous in an acidic solution. So here they've given us the equation for this reaction. And so they say 4 trials were carried out and the results were given in the following table. So here we have some experimental data. Part A, determine the overall rate equation. Okay, so how does a rate equation look? Essentially, it will be K, which is the reaction constant, times the participating reactants, the concentration of the reactants. So we have, for example, BrO3 minus, BrO3 minus to the whatever order that it is, then Br minus to whatever order that it is, and H plus to whatever order that it is. So we need to find out what are the orders of this reaction. Okay, so first let's find out the order for the bromate ion. So how do we find out the reaction order? Well, we need to change the concentration of the reactant to which we want to find the order while keeping the concentration of the other reactants the same. So for instance, you have the only two concentrations for bromate are either 0.5 and 1. So we have to look at the rows for 0.5 and 1 and see in which of them are the Br minuses and H pluses concentration remaining constant. So for instance, let me take a look for the row between experiment 3 and experiment 4. So clearly this is times by 2, but this is not remaining constant. You see the BrO3 minus column, that concentration is changed, which is what we want, but the concentration of Br minus and H plus, those are not kept constant, and because of this we cannot make a good comparison to find out the order. So this 3 and 4 cannot work. So what about 1 and 3, experiment 1 and experiment 3, these two? Well, I can clearly see that bromate is increasing by a factor of 2, Br minus and Br minus, that's kept constant, that's good. But H plus and H plus, this is not kept constant, right? This does not work because we need them, all the other reactants to have the same concentration. So experiment 1 and experiment 3 cannot work together as well. So finally we're left with experiment 2 and experiment 3. Okay, these two, let's see. Okay, bromate, the concentration of bromate is doubled, that works. The concentration of Br minus is kept constant, and the concentration of H plus is kept constant as well. So we can use these two rows to find out the order for this particular reactant. Okay, so when the concentration of bromate is doubled, I can see that the initial rate is also doubled. Okay, so when both the concentration and the rate increase by the same factor, or increase or decrease by the same factor, we know that the reaction is first order. So I can say that BrO3X is first order. Next, we can find out for Y, and this is the rule of thumb. When your concentration is increases by a certain amount and your rate also increases or decreases by the same amount, that means your reaction is first order. If I increase or decrease my concentration by a certain amount and nothing happens to my rate, that means I am 0th order. And when I increase or decrease my concentration by a certain amount and the increase in rate or decrease in rate is exponential to the increase in concentration, that means that the order will be the second order. Okay, so just keep that in mind, write that in your notes, and let's go to the next one. So X, the order of bromate, is 1. Okay, What about y? What is the exponent y? The order of Br minus. Okay, so we want to, let me erase this previous stuff, and now let's apply the same principle to find out the order of Br minus. I want to double or change the concentration of Br minus while keeping the concentrations of the other reactants the same. So let's see. Let's try experiment 1 and experiment 4. Okay, so I can see that clearly the concentration of Br minus is doubled, the concentration of BrO3 is kept the same, and the concentration of H plus and H plus is the same. So 1 and 4 work well together, and I can use this to find out the order of the Br minus reactant. Okay, so when I double my concentration of Br minus, my rate also doubles. And what did I tell you before? When the increase or decrease of the concentration is equal to the increase or decrease of the rate, well, the factor of increase, that means it's the first order as well. So this is also first order. And finally, for H plus Z. Now let me erase all this and let's find out what is the order of H plus hydrogen ion. Okay, so I want to change my hydrogen ion's concentration by the same amount. So let's, for example, try experiment 1 and 2. What happens? I can see that my H plus is doubled, my Br and Br concentrations are kept the same, and BrO3 and BrO3 are also kept the same, right? The other reactants are kept constant, and the concentration of what I want to measure is changed. This is what I want. And so when H plus concentration is doubled, the rate of reaction goes up by 4, right? And 4 is an exponent, is exponential to 2. So I know that Z is 2, second order. So from what I've concluded, the final rate, the rate equation, I can replace the x, y, z with the number. X is 1, y is 1, H plus is 2. So this will be your rate equation. Okay, let's go to the next part. The rate of reaction at 50 degrees Celsius is 3 times the rate at 25 degrees Celsius. Calculate the activation energy in kilojoules per mole for this reaction using sections 1 and 2 of the data booklet. Okay, how can I calculate the activation energy? There's a formula given in the data booklet. It is this: ln of K1 by K2 is equal to EA over R into 1 minus T1, 1 minus T2. This is an equation that's given in a data booklet, and this equation essentially helps us to compare the same reactions with two different rate constants like it is there in this case. Let me explain. I know that this is the same reaction, but I also know that the rate of reaction at a particular temperature is 3 times the rate of reaction at a different temperature. If the concentration and the order of the reaction is kept the same, the only thing that's changing in order for the rate of reaction to change is the K constant. And so I know that the ratio of K constants, K1 is to K2, will be 1 is to 3. Okay, so I can write that here. ln 1 is to 3, right? That's the ratio of the rate of reactions and also the ratio of the K constants, because that's what it tells us here. And that's equal to EA over R 1 minus, what is T1? T1 is 50 degrees Celsius and T2 is 25 degrees Celsius. Now I want to convert Celsius into Kelvin. So we can do this. 273 plus 50 is how much Kelvin there is for the first reaction. So that is 323 if I put that on my calculator, minus 1 over T2, which is, actually I don't need to write T2. What is it on my calculator? We just do 273 plus 25, and that's 298. Okay, and now I can rearrange this for EA. So how do I do that? Let's see right here. And I also know R is 8.31 joules. It's in joules, right? I want it to be in kilojoules, so I have to divide 8.31 by 1000. So let's do that now. So all I have to do is say ln 1 over 3 times by 8.31 over 1000 by this right there, I'm bringing it to the other side, 1 over 323 minus 1 over 298, and this will be equal to my activation energy. Okay, so let's find out. Let's put this on our calculators. So we have ln 1 over 3 times by 8.31 over 1000 divided by 1 over 323 minus 1 over 298. And what do I get? I'm getting that activation energy EA is equal to 35.15 kilojoule per mole. Okay, thank you for watching. Please like and subscribe. If you have any questions, leave it down below and I'll answer it as soon as possible. Thank you for watching.